Okay, today's a new one, 10.3. And basically now Trig has gone 3D. I don't know if you noticed, but all the triangles we've drawn so far have always just been flat triangles. There hasn't been any height involved or a 3D scenario. It's always just been maybe a person walked on the ground this way and they walked on the ground that way, but everything was on the ground. It was always two-dimensional. So how do you make it 3D? Well, one of the things you got to be able to do to actually draw 3D pictures well is to be able to, instead of doing this, which is what we did when we had those, like the guy walks this direction, and then we start a new one and he walks that direction, and then how far is he from home? Those are good problems, but that's all two-dimensional. But we need something like this, except we need it to look 3D. So here's what we do to give us ourselves that 3D feeling, even though I think you all know we're still going to be writing on a two-dimensional surface, and you can't really, we just have to fake ourselves into thinking it's 3D. Would you draw for me a parallelogram, like a tilted over rectangle? Draw one of those. Make it largish so that you can make something inside it. All right, now on the inside of it, make a line that matches the same angle as the two sides. It's parallel to the two sides. And then another line that's parallel to the other two sides. And you might ask, didn't you just turn a plus sign sideways? Didn't you just take this and turn it to the side and go like that? No, I did not. Because if I really had done that, these would all be 90-degree angles. And it would not give us that great 3D effect. Okay, now imagine for a moment that that is you looking down on your backyard from a drone. And in that plus sign is where you're going to put the flagpole. Have it go straight up from there. Notice, had we done it the old school way where it was a compass rose, then your flagpole would be going on top of the north direction and you would lose all your 3D-ishness. So anyway, back to, you're looking down at your backyard and you put a flagpole in the middle of your backyard. Okay? Now, to make this a typical problem, I'm going to give you the directions and then I want you to see if you could draw out what I said. Put a little N, capital N right there for north. That'll help. So now, what I'm asking is, here's your scenario. You just put a flagpole in the backyard, but you forgot to measure how tall the thing was. You know it's kind of tall, but you don't want to know actually how tall is that thing. Okay? So you start at the base of your flagpole and you walk directly south 10 paces. I want to tell you, your flagpole, you're not going to be able to climb up it to see the height, but you can find this by knowing some simple things like a pace. A full pace is about 3 feet. Okay? So if I just said to go 10 paces from your flagpole, how far did I really say to go? 30 feet. You're going to use this because part of your homework for today is to go home and use the technique we're about to talk about to see how high something is in your backyard. Like, I have a bunch of trees in my backyard, okay? And I'd love to know, is that a 40-foot tree or is that a 60-foot tree or how tall is it? All right, so I'm going to have you hike, just walk, from the base of that tree a certain number of feet, okay? And you can do any distance you want, whatever works well for you. And then we need to measure the angle that you sight to the top of the flagpole or tree or whatever it is you're trying to find the height of. So so far, does your drawing match mine? Where that, I was off just a little, I'm going to try again. I want to be right on that south line. There we go. Where that was 10 paces or 30 feet. And now I'm going to just connect up to the top of the flagpole. And now I got a right triangle. Once again, it always comes back to right triangles. Even on the non-right triangle section, all we did was find right triangles that were nearby that would answer our questions. Okay, so this guy, do you agree I've got a side, but I don't have any angles yet? All right, something that's kind of cool on your phones. Everybody, you almost never hear your teacher say this, take out your phone. if you have a smartphone with you today, if you don't, I'd like you to try this on the iPad and look for something that measures angles on your iPad. But if you have your phone, it's so slick. Also in surveys, I find that typically it's about 80% of people have an iPhone, and the other 20% have Androids or whatever. Okay, for you Android people, I think there's a compass built into those also. Can anybody verify that that's got an Android? It does have a compass. Okay, cool. Now, first off, a compass cannot measure to the top of the flagpole, but if you've got the compass up, which by the way I do by swiping down on the surface of my phone, and then I type in search and I type for compass, and then boom, I got my compass. And you guys have all seen the compass before, I'm sure. Okay. First of all, I want you to realize how terrible they are in a building. Everybody right now, get your compass going and tell me which direction, by pointing, which direction your compass says is north. Now look at the hands around the room. Isn't that crazy? We have people pointing completely opposite directions for north. All right, so my moral of the story here is don't use this indoors. Now, I'm not saying that the compass is terrible in general, but indoors, they're terrible. Why? Because they have all kinds of interference. I think it's the big metal beams that are in the school that hold up the school, hold up the roof and stuff. Metal is known to throw off compasses, and so that's my theory anyway. So the compass is not what we're using, but watch this. Swipe to the left or to the right, and boom, you instantly have angles being shown to you. It's your phone's ability to know where it is in time, not in time actually, in space. Okay, now here's a challenge for you. Try to hold it perfectly so that in every direction it's 0. Really tricky to get everything perfect so that that phone is completely level with the, or parallel to the ground in all orientations. Ooh, I had it for a second there. There we go. And do you see it turn green? If the screen turns green, you've got your phone perfectly flat and like parallel to the floor. Okay, that's just for fun. Now let's see how you could use this to measure an angle. I'm sighting along the side of my phone. I want you to watch me do it now, okay? I am sighting to the spot where the roof, the ceiling in this room, touches the wall, okay? And I am trying to make this be perfectly on the line between my eyeball and that crack up there. Can you guys tell me what angle it's saying to you? 16, 15? 16, okay. Now, it helps to have somebody read that to you, but there is a hack. Okay, if I hold it up here, well, there's a way to do it without somebody to help you. It's tough to hold this up and then touch, like that, and it doesn't freeze the number, but it creates a new line. Here, let me try it one more time here. So that now when I bring it back to level, I can see, oh, I guess I was at 16 degrees. See what I'm saying? So by touching it, you then have to re-level it, and it's kind of complicated. It's much easier if there's just a person standing next to you that reads the number to you and it says 16 or whatever. Okay, now one more flaw with this. I'm going to draw out what I just did here. Here's me, and here's me holding up my phone. And I was getting the angle up to that corner of the room, and I can know the distance to that wall, and then I can figure out this height here, the height of my room, right? No, that's the height from my eyeball to the top of the room, and if I knew this number, I could know the whole distance. You see what I'm saying? My right triangle is 5 feet off the ground approximately. I'm going to let you use the estimate that your eyeballs are about 5 feet off the ground. I'm thinking that's the closest number that we can get that's a whole number to make your life easier, okay? So do you get when I was done, I'd figure out this, and I'd have to add 5 feet to it? to get the true height of the ceiling? All right, because you're not. If you want to try to sight from the floor, very difficult. You have to lay your eyeball on the floor, and be able to turn and look up the iPhone, which can't. The angle won't work well for you. And anyway, it's a real pain. So I just stand up and do it, and I'm going to allow you to all assume that your eyeball height is 5 feet. If we wanted to be super accurate, you could measure that in inches or whatever, but just use 5 feet. All right. Now, given this scenario, and you just had told me that that was 16 degrees. Now I'm going to measure, this is rough, but paces. 1, 2, 3, 4. I'm going to say it was about 5 paces, which would be 15 feet, but I'm going to say that last pace was a little bit short. I'm going to say it's 14 feet. If this was 14 feet, and it was a 16-degree angle, would you please figure out for me, factoring in my height, what is the height of our ceiling? I'm going to pause for a second while you try that one. Okay, I'm hoping this was not rocket science. You just had an angle on a side, and then you can figure out anything, right? I would have used tangent of 16 is equal to h over 14. And then I'm going to move this over and say it's 14 times the tangent of 16. But then when I'm done, what do I got to remember? Add 5. Okay, so what did you get after you added 5, Mr. WR? Can anybody verify 9 feet approximately? Okay, now just look at that ceiling. Does that feel right to you? Okay. If I can touch the ceiling by jumping, that means it's for sure not 10 feet, right? If I can touch the ceiling by jumping? All right, no, you're not going to get to see that today because I don't think I can do it. Maybe if I stretched out and warmed up, maybe. All right. But I think you're going to get to see Mr. S do it. Okay, show us how easy it would be for you. You can get the ceiling, right? You're a giant. There we go. Okay, cool. Now, if you were 1 foot taller, that's how easy it would be to touch the rim on basketball, right? And that's a huge advantage, obviously, have that height. All right. So, yeah, it's 9 foot ceiling in here, and that makes sense. All right. What if I said it's actually not a 9 foot ceiling, it's actually a 10 foot ceiling? Can you explain? Yes? Okay. The eye height thing could definitely be off. Okay, that's definitely a factor. Yes?
The angle.
The angle could have been off. I was just roughly doing that angle, right? That was not perfect. Yes? The what? I paced it. That is not super accurate. There's 3 chances for us to screw up. What if they all go in the same direction? It could be way off. But I can tell you the ceiling's about 9 feet. So it was pretty, maybe our mistakes were going in opposite directions and it all worked out. One other thing, look at those ceiling tiles. Did you know if you push them aside, there's actually the actual real ceiling is not that. The real concrete ceiling is another 1.5 feet or 2 feet above that. So it all depends on how you want to argue how high it is. That's a false ceiling right there. But to the ceiling that we can see, it's about 9 feet. All right, moving on. So let's say that you have height 30 feet here. Now, do you get that we need an angle here? Imagine for a moment, just to keep our lives a little simpler here, that you can lay your eyeball on the lawn and look up. And so in other words, you don't have to factor in the 5 feet thing. And you get this angle to be a 60-degree angle. I'd like you to figure out for me, how high is that pole in your backyard? How high was the flagpole? There's a way to do this without the calculator, but I'm totally fine with you using the calculator. So I'm thinking, I got opposite, I got adjacent. I'm going to use tangent of 60 is equal to h over 30. So 30 times the tangent of 60. And I happen to know what the tangent of 60 is. Tan 60 comes from this. Here's my 30, 60, 90, right? Doesn't take long to draw this. 1, 2 square root of 3. What is the tangent of 60? That's tangent of that. Tangent is opposite over adjacent. Root 3 over 1, it's root 3. So 30 root 3. You get how if you used a calculator, my answer's better because mine's exact. All right. Yes? All right, let's check. I multiplied both sides by 30 right here so that I could get h alone. I think it's 30 times tangent of 60. So I think I did it right. And the tangent of 60, just to double check that, the tangent of 60, I said it's the square root of 3. Here's 60. Tangent is opposite over adjacent. Yep, I did it right. 30 root 3. All right, so anybody else see something wrong? Because I know every now and then you just get your head around something wrong, but I think I got that right? Okay, good. Okay, so now let's add in one more twist. I want you to get a new one here because now we're going to go and make it truly 3D where we're going to have a spot over here kind of thing. All right, so get a new one. And again, to start with drawing that shape, which is called a what? Parallelogram, and then you make your little plus sign in that, and then you make your pole. And this time we're going to say that you are in Washington, D.C. There's something called the Washington Monument. Super tall tower, right? Okay, I've never seen it, but I've heard about it. It's one of those on my bucket list, got to get to Washington, D.C. someday. All right, and then let's make a tower going up here. Can you picture yourself at the base of the tower, being able to walk away from the tower, turn, use your iPhone, get an angle to the top of the Washington Monument? That's all doable, isn't it? Okay, so let's say that you walk 20 paces, which would be about how far? Times 3 is about 60 feet. Okay, 20 paces directly. Let's make it directly, this is north. Make it directly east. 20 paces directly east. You turn. We're going to use your height as 5-foot eyeball. Okay, so factor that in at the very end. I want to know if you got us an angle. Has anybody been there? Somebody here, oh, quite a few of you. Wow. Okay, imagine this scenario then. You've seen how tall this thing is. I know it's pretty tall, but I really don't know how tall. If you had to guess, if you go 60 feet out, 30 paces, and you turn and looked up at it, how big of an angle are we talking for our angle of, what's that called again? Angle of elevation. Good. What do you think it would be? Somebody has been there. Give me your best guess. Would it be super steep, like an 80-degree angle? Or would it be 70? All right, we're going to use 70. Okay, so assume it's a 70-degree angle once you get 60 feet out from the base. And I want to know, how tall is this thing? And then the problem gets more complicated. But for right now, all right, if you drew this properly, east is this way, and we go 60 east, and then we had a pretty big angle here, a 70-degree angle of elevation right there. This is really no big deal. You got an angle, you got a side, you can figure out the height. What's there to forget? What's easy to forget? The 5-foot height. Don't forget to add that in. So, did you say, once again, tangent so often is the thing. Tangent is TOA, opposite. Tangent of 70 is opposite, which is h, over adjacent, which is 60. So it's 60 times tangent of 70. I have no idea what the tangent of 70 is, but you guys with a calculator probably do. And then multiply it by 60, and then add 5 for the extra height of your eyeballs thing. And what did you get? Yes, sir. 169.8. Can we round that to about 170 feet? Raise your hand if you had that one right. Okay, good. Now, I'm completely aware that we probably just totally destroyed the actual height of the thing, but we were totally guessing on that angle. You get, it wouldn't be that hard to pace 60 feet. That part we can do. And the height is about 5 feet. That part we can do. So it's all about the angle. So what if we looked up the height of the Washington Monument which wouldn't be that hard, which you already did. What'd you get? 555 feet. So then now we got to change it. This is 555 feet. What is the angle? Use your big brain and figure out what angle it would have been. I think maybe the angle was steeper than we thought. Quite a bigger than 70. What I'd be doing is tangent of theta now, some unknown angle, is 555 over 60. So then how do you solve that? Inverse tan. Inverse tangent on both sides. So in the end, what we have is the inverse tan of 555 over 60. And get me out of suspense. What is it? Oh, wait. Oh, yeah. How about, oh, we do have to do it now. I thought we would do it at the end. Very valid point. If it's really 555 feet, your eyeballs are up 5 feet. This should be 550. Oh, good catch. Granted, the degree will be off only probably a 0.2 of a degree, but let's do it right. Thank you for catching that. And we have inverse tan of 550 over 60. Give me a final. What'd you get? Got an answer? No answer yet? How about you? 83.7. Can anybody verify 83.7? Okay, good. All right. Now, that is not even a hard problem. It really isn't. But we could change it to make it more difficult. Keep the same start. But now do this. Now I want you to travel some unknown distance straight north. Straight north. From where you were right here. Travel some unknown distance straight north. Do you get I need to make another one of those compass roses? And do you get I need to not do it like this? I got to do it with the same angles I had before. I got to copy this little guy right in there perfectly right here. If I just stay parallel to this, that would work. And then if I just stay parallel to this, that would work. Okay, so you want to head directly north some unknown distance until the angle decreases from 83.7 down to 80. Draw that scenario. And then the question would be, how far did you walk? Unknown distance straight north. Goes up that way. Do you get that this on the ground is a 90-degree angle because you were going straight east and now you're going straight north. That makes it a 90, right? Some unknown distance, I'll call it x, until this angle right here was 80. Why would it be a smaller angle? Wouldn't you agree that it has to be farther away from the tower? Here, I'll use this blue one. Do you get that that distance is a hypotenuse that has to be bigger than 60 was in the first place? Do you get that that angle would have to be smaller than 83? Because it's further away from the tower. The further you go from the tower, the angle gets smaller and smaller, right? Okay, so it all works, but it's not easy to do. You're not ready to actually solve that yet, but that's kind of where we're headed, and that'll be like the ultimate, most difficult thing that you could be asked on this test. That kind of thing. 3D with more than one triangle involved. All right, so your job for tonight is twofold. Number one, in class, before we move to the homework, you're going to do one more of the kind of problems like yesterday where it's not 3D. Back to just bearings of a ship sailing here and a ship sailing there. You got to practice those and make sure you're good at that before we move on to the 3D stuff. And then part of your homework for tonight is to measure something tall in your backyard. You can use a pace, is about 3 feet. You can use your phone to take that angle. And I don't want to discriminate against people who don't have a way to find that angle. So you do the problem and you may just guesstimate the angle that you are looking at for your angle of elevation. We'll all use 5 feet as our height of our eyeballs. Okay, and then I'd love for you to know from now on, of course the tree's going to grow, but how big that tree in your backyard is from using this technique. Okay? You can know if it's a 50-foot tree or whatever. Maybe it's a telephone pole. If you do a telephone pole, the good thing is it won't grow. So you could probably say for the rest of your life, I know that telephone pole is 35 feet tall because I figured it out in math class. All right, so that's part of your homework for tonight, and you'll just have 2 other little problems that aren't super bad. Okay, so that's the homework for tonight. All right, so one last thing in class then is let's do one of those ship problems. And this one, I want you to be working with someone. So would you please slide next to rows 1 and 2, 6 inches apart. Rows 3 and 4, 6 inches apart. You 2, 6 inches apart. Yes, you may. All right, and let's see where we have a gap. We have one. Would you come on over, please? Yes, you may. Does it work? Right there. There you go. Okay, good. Okay, so this one is not 3D, so you can use normal compass rose to start with. Everybody put a compass rose in the lower right-hand corner. And here is my problem. I want you to go at an angle of true 280 from here for 1 mile. True 280 for 1 mile. Then I want you to head directly south for 4 miles. The question is, if your starting place we call home, how far are you from home? And what bearing should you travel at to get back home? Okay, so generally it should look something like this. And the question is, you don't have a right triangle. That's what makes it challenging. How far are you from home? And what bearing would you need to travel at to get home? All right, remember, you don't have a right triangle, so you got to use other right triangles that exist nearby, like maybe that right triangle. Or maybe you got to use, oh, there's probably 3 of them that you could use. All right, so make a compass rose at the end of every place you stop, too. It really makes a big difference. Kids that try to do this without the compass rose, a lot harder. Okay, I'm going to pause for a moment while you guys give that a shot. Okay, just a 2-minute for setup to make sure you didn't screw anything up. Generally, it should look kind of like this. And what you're trying to find is that length of that pink line and the angle that you would need from here, what angle you would need to travel at, which basically looks like it's, I don't know, it looks like it's like 60 degrees or something, but you'll have to figure out what exact bearing you should take and how far it will go. Like, how far is this? Okay. I'm going to call that D for distance home. Trying to find D. I'm going to pause for a moment again while you give that a try. Okay, I've had a good question. Some kids are done already, which is awesome, and they want to know what the homework question is. So everybody, just for a moment, look up and let me tell you what the homework is. All right. I would like you to do these 2 what we call practice problems. They are labeled as practice problems as your homework for tonight. And that would be way too easy, except I've also asked you to do the find the height of something tall in your backyard thing. Okay? So officially, the homework question about the height of something in your backyard, use 5 feet as the height of your eyeballs. Use your cell phone to find the angle for you, and if you don't have ability to do that, estimate the angle. And then pace to the tree, or whatever this thing is, and get a total feet that way. Then, practice problem, that's our 12-minute warning. Practice problems, this one and this one. The green one is the one that's a 3D one. Okay, so the green one and the, I don't know, whatever that color is, tan, khaki one. Those 2 practice problems. That's it. All right. I'm going to pause while you continue this problem. Okay, let's hash through this problem and see. Some of you probably got stuck. I wouldn't be shocked at that, but your test that's coming on Monday, at this point, you're still wavering. It's going to kind of depend on how things go the next couple of days. It is possible we move it up to this Friday. And there's good things and bad things about that. If we move it to this Friday, obviously, we'll have to only review on Thursday. But then you won't have homework over the weekend, which is nice too. So anyway, I'm throwing it out there. There's a chance it'll be Friday, but kind of depends on how we're feeling about you guys and how you're doing on your homework and stuff. So anyway, this problem is one of the kinds you'd have to be expected to know. I would have started, nope, not there actually. I would have started with this triangle. Do you know why I am attracted to that triangle? Yes, sir.
You can find like both sides to a triangle, or you can find like 4 minus whatever your one side is.
Okay. I like triangles where I have one side and one angle. Would you agree I have a side of this one? That's one. And would you agree that I have an angle of this one? Because as soon as I have that angle, which is 80, and one side, I can find everything about it. Okay. Now, I don't need to just find everything about it, but actually I'm going to end up using everything about it, so I may as well. Okay, this side right here, I'm going to keep it short by not having to actually type in anything in the calculator. But that side there, I'm going to call x. This I'm going to call y. And I'm going to find x by going, my angle here is 80, and I would use cosine as adjacent over hypotenuse, so it would be x. So cosine of 80 is x over 1. Do you get I just really easily know that x is cosine of 80 then? Cool. Okay, then this side here, I could know that is sine of 80 is y over 1. And that worked out really nice. So y is sine of 80. Okay? And now, do you get that another critical triangle here is this one? I'll use the blue bars to make it. This, and this, and that. Because I don't, right now, have a side in it or an angle in it. But now I just found a side. See what I'm saying? I just found y, which is going here. I just found y, which was cosine of 80. So that means this side right here is cosine of 80, which is some decimal. Cool. All right, I got one side. Now I just need an angle, and I got it. Or another side. Because if I could find another side, then I'd have two sides of a right triangle. And that's the way I'm going to go. Do you get that I can find this side really easily by taking 4 miles minus that side? This is important to get. Let me show it to you with big blocky red lines here. This minus this would give you this. That make sense? So 4 minus this side over here was cosine of 80. 4 minus the cosine of 80 is how long this is right here. And that means I got two sides of my right triangle. Then I can find the length. And once I have this length right here, then I've got two sides which can tell me this angle. Actually, I can find the angle before I even find the hypotenuse. I can find this angle by doing tangent of theta is equal to opposite over hypotenuse, and the opposite one was 4 minus cosine theta, or cosine 80, sorry, over, tangent is opposite over adjacent, and so the adjacent one is cosine 80. All right, cool. Wait, sine 80. Sorry, y, which is this, is sine 80. If you were copying notes down really carefully, change that to a sine, and then this is sine 80. I caught myself. Usually you guys catch me. Okay, so that's something that you got to be able to handle. I know they're tough, but we've practiced it twice now. You can expect to see it again. So the last kind is the new thing that we were just doing for this homework, which is, I just want to remind you, on your tower problem, please start by making yourself this kind of a compass rose, and then have the tower height come up out of that. So much easier to see it in 3D when you go like that. Okay, that's all I got for you for today.